excited to have you. And as Hayden mentioned, my name is Fritz, and I'm a software and control business leader with Rockwell Automation. So Jeremy and I are going to share some insights today that we hope will resonate with you. So we're gonna take you through a little journey today. So for manufacturers, regardless of industry, right, discrete, hybrid, process, this general concept is the same. This is very simplified, but you take raw materials or unfinished goods and they do something to them. Mix them, machine them, assemble them, package them for sale to customers or to distribution. And what are these manufacturers trying to achieve? What are their goals? With lots of collective experience in the industry between Jeremy and I and our distributors, this is what we're hearing. Our customers want to do these things. They want to optimize production, right? And what does that mean? That means increasing production while reducing cost, which ultimately leads to increasing profitability. And that ultimately is the secret sauce. That also means improving quality to increase market share in their respective industries. They also want to empower their workforces. It's no secret right now that talent acquisition and retention is a real challenge. So how do we empower our teams so that they can contribute and feel valued and needed? How do we onboard quickly and transfer knowledge from person to person? Also managing risk, and not only managing risk, but mitigating. Identify, assessing, and controlling risks that threaten an organization's capital and earnings. So this can be anything from cybersecurity risks, risk to human life, and the risk that comes from downtime. Also, driving sustainability. So this is a big deal right now. We don't talk to many companies nowadays that don't have an ESG framework, right? It's a huge trend. So businesses are integrating a sustainability strategy to improve operational efficiencies and drive down costs. Efficiency improvements can boost operational profits by up to 60%. Not only is sustainability good for business, but we want to leave the planet a better place for the next generation. And finally, and most importantly, accelerating transformation. With the acceleration in technologies, our customers know that in order to remain relevant in their respective industries and markets, they must accelerate transformation in their manufacturing operations. So we believe that these are our customers' goals. So where a customer is on their journey to get to their goals, or what they're trying to accomplish, is a measure of their digital maturity. So down at the bottom is a digital maturity scale, right? You've got everything from level 1 to level 5. Level 1 is kind of the basic, right? Paper tracking, moving parts manually from machine to machine. If you've got a quality problem, you write it down. All the way to level 5, which would be, lights out, self-healing, completely automated digital facility. I've never been into a level 5 facility. The reality is most of our customers are somewhere between a level 1 and level 3, with probably most landing around a level 2. We could argue this, but the reality is that most are still adopting Industry 3.0 technologies, with smart manufacturing being their goal. So if customers can adopt smart manufacturing, they can achieve these goals. And that's what brings us here today, and this is important. Smart manufacturing requires modernization. These rapid advances in automation, equipment, and networking technologies accelerate the pace at which production systems approach obsolescence. In the age of the connected enterprise, success will be driven by intelligent equipment, networks, and devices that leverage the latest innovations. Okay, so that was a lot. So I'm going to repeat it again because this is important. Smart manufacturing requires modernization. These rapid advances in automation, equipment, and networking technologies accelerate the pace at which production systems approach obsolescence. In the age of the connected enterprise, success will be driven by intelligent equipment, networks, and devices that leverage the latest innovations. Okay, So moving on. Adopting smart manufacturing will raise the digital maturity across your facility or across your enterprise. So let's talk some details about Industry 3.0 and 4.0 and dive a little deeper into our customers' goals and objectives and why they're important. Jeremy?
Thank you, Allie. So being close to the university, I could not resist actually giving somewhat of a lecture on history. So y'all guys are going to have to deal with that for a few minutes. So I want to start with the third industrial revolution. It actually began in the latter part of the 20th century, and the use of digital computers, digital record keeping marks its beginning. And as Ali alluded to, it continues to this day. We got customers who are still working on those type of technologies. But the mass production and widespread use of digital logic, transistors, integrated circuits, and the derived technologies such as computers, microprocessors, cell phones, and the internet have fueled the third industrial revolution. These technological innovations have transformed the traditional production and business techniques. In the manufacturing sector, it gave rise to PLCs, drives, HMIs, SCADAs, and a whole host of software. So it allowed us to actually replace the electromechanical controls of that day. Now, what actually came out of the third industrial revolution is kind of interesting, because if you look at the internet, it kind of went on its separate track, if you will. And what I mean by that is it became the global network that we know today that allows people to communicate, share information, and conduct business. The other technologies had the ability to create lots of data, and they did. But they were not immediately connected to other systems or to networks or to the internet in any way. So what did this lead to? I'm sure you heard this term before, data silos. But integrating these technologies with the internet and communications is actually the backbone of the fourth industrial revolution. So that's your history lesson on the third. So now on the fourth, we're actually in that right now. Some would say what we really have is a continuation of the third, and there's really not a fourth. I would disagree with that, because you can see a clear line between the third and the fourth when you start looking at the fact that we've taken the controls that were developed in the third, or the technologies that were developed in the third, and integrating them with the communications. Remember I said that there was that kind of a split, right? So it is the fusion of these technologies that started in the third industrial revolution and blurred the lines between physical and digital. Now I need to be clear here. When I say those technologies, I'm talking about the use of families of technologies. In other words, what I'm saying is computers, PLCs, software, and communications. I'm not referring to necessarily taking your older technologies and just using them in the fourth industrial revolution. I'm not saying that. I'm saying those families are still there. The older versions of those technologies cannot be used to reap the full benefits of the fourth industrial revolution. Hence, that's why we're here, to talk about modernization. So just like the internet allows humans to share information to make better business decisions, the fourth industrial revolution is providing the ability to break down those data silos that we saw in the third industrial revolution and allow analysis of a large amount of data. It's allowing the sharing of data between systems and to perform analytics on that data. In essence, it's allowing machines and systems to converse with one another and to make decisions with little or no human interaction. That's what the fourth industrial revolution is really about. Overall, the fourth industrial revolution is expected to significantly change the way we live and work, and we've already seen some of that. Individuals, business, and governments need to be aware of these changes and be prepared to adapt them. So let's talk for a minute now that I've given your history lesson. By the way, there's going to be a quiz when we're all done about that, so be prepared. The fourth industrial revolution, what does it actually give us, or what are the actual benefits? Let's dive into that a little bit. Now, you have probably heard the term Industry 4.0. They're kind of used synonymously, meaning the same thing. So the first thing we get, as Ali alluded to, is optimization of production. That's one of them. And by empowering the workforce through the use of digital twin technology is one way we can do this. So, but what is a digital twin exactly? A digital twin is a virtual replica of a physical asset or product or process that allows real-time monitoring and analysis of the performance of the physical asset, product, or process. I know that's a lot. So how is a digital twin actually created though? It is created by collecting data from sensors or other sources, such as simulation models, and then using that data to build a digital replica, again, of the physical asset, product, or the whole entire process. And Hayden spoke earlier about a breakout session we're going to be having, and it's called the design process. And in this session, we're going to talk about a couple products. One of them is Emulate 3D, and it is a dynamic digital twin software for virtual commissioning, throughput simulation, and industrial demonstrations. And then there's a Logic Echo, it's the other product. And it is an emulation software for our ControlLogix controllers for prototyping and design and testing and evaluation. Both of these products reduce risk, save time and money through every stage of the project. Now, once we have this digital twin created, how can it be used? Individual manufacturing or industrial manufacturing, in industrial manufacturing, digital twins are used to simulate production processes. Manufacturers can create virtual representations of real-world product, equipment elements, production processes, or whole systems based on data collection from Industry 4.0 solutions, sensors connected to machines, and machine tools. These simulations can help track machine operation, and here's the key, adjust it in real time for production processes. With the use of machine learning algorithms, digital twins can help manufacturing companies identify problems before they occur and predict a future outcome. Now that's powerful stuff when you think about it. But from a maintenance standpoint, a digital twin can capture real-time data on equipment operations and augment it with historical data of failures that have occurred in the past, along with contextual maintenance data, and use it to recognize potential issues quickly or again before they occur. With the help of machine learning and artificial intelligence, predictions can be made when maintenance work is necessary, not on a routine schedule. Again, think about it. That's powerful. Based on the data, companies can make proactive measures to prevent production stoppages. It is important to note that implementing Industry 4.0 technologies, I'm not going to hide it, requires a significant investment. Companies need to ensure that they have the right expertise and the support to make the most of these technologies. Additionally, it also brings in new ethical, privacy, and security concerns that need to be addressed. So let's look at empowering the workforce. One fundamental way Industry 4.0 technologies can empower the workforce is through advanced technologies such as augmented reality and virtual reality. Sounds like we're getting in a video game, right? These technologies can provide workers with real-time information and guidance and assistance that can help them perform their tasks effectively. For example, workers can use AR to overlay digital information, such as assembly instructions, onto a physical components that they are working on, reducing the chance of errors and increasing efficiency. Rockwell actually has two examples this type of a product. One is called Before You Expert Capture. This is an AR-based training and guidance product for the workforce. Now, there are over 10 million jobs in manufacturing organizations that cannot be filled due to a skills gap problem right now. Paired with a retiring workforce and strict compliance and safety requirements, it's easy to see how a technology such as this can be used. Rockwell's Before You Chalk brings expert technicians together with real-time problem solving and collaboration via mobile devices. Technicians and experts can draw digital annotations on a mobile screen or on a desktop that actually stick to the physical 3D, to the physical objects in the real world, allowing experts to guide those technicians through a step-by-step process of troubleshooting and repairing the equipment. In other words, that skill gap challenge we're talking about, how are you going to address that? This is one way it can be done. This type of empowerment is actually called, it's got a term for it, it's called an augmented worker. So the term augmented worker refers to the use of digital technologies to enhance the capabilities of the human worker. The idea behind it is the use of technologies to assist the human instead of replacing the human with full automation. It is accomplished by equipping human workers with advanced digital tools and technologies such as the smart glasses, head-mounted displays, mobile devices, wearable devices, and can provide them with real-time information and guidance and assistance. Augmented workers can benefit from a variety of digital technologies, and we've talked about a few. Augmented reality, virtual reality, which we just discussed. But an area of great concern today is onboarding those new workers. VR, virtual reality, allows workers to train in a simulated environment. Artificial intelligence can assist with decision-making, data analysis, and process optimization. The Internet of Things and sensors can gather data from the environment and provide the data most relevant to the task at hand to the worker at that point in time, who can then make the correct decisions. The use of digital technologies can allow human workers to perform tasks more accurately, quickly, and reduce the risk of errors and injuries and increase the overall productivity. Now, Ali would like to talk to you a little bit about risk management.
Yeah, thank you, Jeremy. So talking about managing risk, can anyone in the audience tell me what you think is the biggest risk to our industry right now? That is one, yes. Definitely. Anybody else? Cyber. Yep. Cybersecurity, cyber attacks. So it is estimated that globally, by 2025, that cyber crimes are going to cost the globe $10.5 trillion per year, which is pretty unimaginable. So cyber attacks and the cyber risk is real, and it's very real to our industry as we accelerate digitally and move into this digital transformation space. So, when we talk about managing risks, as more and more systems and devices are connected to the internet and to each other, the number of potential entry points for cyber attacks increases, obviously. So this can include everything from traditional cyber threats, such as hacking and phishing, to new threats, such as IoT botnets and ransomware. So to manage this risks, organizations need to implement robust cybersecurity measures, such as firewalls, intrusion detection and prevention systems, and regular training for employees. So you're all probably aware of what cybersecurity is, but that just refers, to the practice of protecting internet-connected systems, including hardware, software, and data from attack, damage, or unauthorized access, right? So it involves a wide range of technologies, processes, and practices that are designed to safeguard systems and data from cyber threats such as hacking, phishing, malware, and other forms of cyber crimes. There are several main components of cybersecurity, including network security, and that it just involves protecting the infrastructure of a network, such as routers, switches, firewalls, from unauthorized attacks and access. There's endpoint security, and that involves protecting the devices, such as computers, mobile devices, networks from attacks and unauthorized access. You've got application security, which involves protecting the software applications that an organization uses. And then you also have cloud security. As we move more into this cloud space, that involves protecting the data and applications that are stored and run in the cloud environment, such as AWS, Amazon Web Services, Microsoft Azure, and Google Cloud. So, this is, excuse me, this cybersecurity risk is really something that we're trying to educate our customers on as we move into this digital space. And there are many ways we can help assess and manage these cyber risks in your facility, from basic network assessments to security posture surveys, continuous threat detection, to full industrial cyber solutions. And then, another risk I do want to touch on today, and someone called it out, is the threat of part obsolescence and downtime, right? So I'm willing to bet that there isn't an individual in this room that hasn't been affected by the supply chain crisis that we faced in our industry for the past couple years, and that we continue to face today. It's been a real challenge, and because of supply chain constraints, older technologies are being moved through their life cycles a lot faster than they have been in the past. What we used to see with, let's say our processors, I'm just using an example, and this is hypothetical, but, our slicks have been in service for 30 years, right? And they'd go from active to active mature to end of life to discontinued, and you'd have this huge long life cycle curve. Well, we're starting to see things accelerate much quicker through that curve. And because of aging components and because of the supply chain constraints, older technologies using aging components, aside from the chip crisis in general, are really the root cause of the majority of the constrained products. So suppliers are going to provide what's more readily available. And in a lot of cases, they're discontinuing production of those aging components altogether to make room for production of the newer technology. So what happens when a manufacturer needs a part that's made with older technology? It's harder to get, the lead time's longer, or you just can't get it at all. So you're forced to redesign or accelerate a product through its life cycle. So it's really creating, for older products, it's creating this push to accelerate to new technologies. We have parts in Rockwell Automation, to be completely transparent, through this whole supply chain crisis that we've had to go through, over 10 redesigns because our suppliers have discontinued making of parts. So in order for us to continue to supply you the same parts that you've been using for 10 years, we've had to redesign and requalify suppliers to make new, or to put new parts in our components to sell to you. So that's just an example of how the supply chain crisis has affected production and manufacturers. So if you've got old hardware in your facility, and this ties into this modernization conversation, right? Now's a good time to start to put together a modernization strategy, because I'm foreseeing that as we continue down this path, older technologies are going to continue to accelerate through their life cycle much faster. So in the breakouts today, as Hayden mentioned, you'll learn many tools that we have to assist in that process. All right. So, Jeremy, I think you're going to talk a little bit about sustainability to
Yeah.
round us out.
So another area is driving sustainability. So one of the top reasons companies are adopting sustainability strategies are to increase efficiency, add brand value, and meet customer demands, to have a competitive advantage, and obviously to attract talent. So how does Industry 4.0 actually help with this? One way in which Industry 4.0 technologies can help drive sustainability is what we've touched on a lot, is improved product efficiency. So there's two examples of that. One is the use of robotics, right? So you use robotics, you automate repetitive tasks, routine tasks, and improve accuracy, production processes, and reduce the need for human labor. Additionally, you can use advanced analytics and machine learning. Can help organizations identify inefficiencies in the production process and optimize production schedules, and reduce waste and improve overall equipment efficiency. There are some other areas is the use of IoT, big data, and advanced analytics to help optimize energy consumption. By monitoring and controlling energy usage in real time again, we can identify areas for improvement and identify potential energy savings. Industry 4.0 technologies can also support the circular economy. It can help track products throughout their entire life cycle, from sourcing of the raw materials to their disposal, thus allowing organizations to identify areas where they can reduce waste, increase recycling, and use more sustainable materials. And obviously, we've heard a lot about reducing your carbon footprint. Industry 4.0 can help organizations reduce their carbon footprint by optimizing transportation, logistics, and supply chain management. With the use of advanced analytics and IoT, it's possible to optimize distribution of goods and services, reduce the need for transportation, and thus reduce emissions in that transportation. Another area we want to talk about is accelerating transformation. One key way of accelerating transformation is to enable organizations to collect large amounts of data and analyze that data in real time. And hopefully it's become clear after all this talk that I've been speaking so far, is that the fourth industrial revolution is about data. So the use of smart devices with greater capabilities than were around 4 to 5 years ago that can provide greater information and have connectivity options that will allow faster access to that data. Using controllers that have the ability for AI at the local level, and then communication networks to surface that data to other systems for the sharing and additional analysis. As you have heard, data can be used to improve decision making, optimize production processes, and drive innovation. But these technologies, and others like cloud computing, edge computing, 5G networks, can create more flexible, responsive, and distributed production systems, allowing organizations to adapt to changes in demand and respond more quickly to new opportunities. Now, there's some key points that we need to remember out of all of this. One is that it is not a one-time event. It is not a destination, but is rather a continuous adaptation and innovation. Organizations need to have a clear strategy and a plan to fully leverage these technologies, and to continuously evaluate and adjust their strategies as new technologies and trends emerge. We need to stop thinking of assets as isolated pieces of equipment, but as components of an overall system that extends beyond the plant walls. It requires, again, a significant investment, both in terms of technology and human resources. As such, it is essential for organizations to carefully evaluate cost and benefits of implementing these technologies, and to ensure that they have the necessary expertise and support to make the most of them. And that is where ES&E, Rockwell, and its partners can help. Hallie?
Yeah, thank you, Jeremy. So in closing, We want to partner with you on this journey. As Jeremy said, this isn't something that just happens quickly. It's a strategy, it's a journey. So if we can understand your goals and ultimately what you're trying to achieve and understand where you are along the digital maturity curve, we can share technologies, capabilities, and solutions we can offer to assist you in meeting your goals. And if we do all of this well, I believe we earn the right to be your trusted advisor and partner on this journey. So thank you for your time this morning.